All right, arithmetic sequences as linear functions. So you need to remember back to chapter 1. Okay, in chapter 1 we talked about functions and writing function rules. We did something like this. Okay, this was a common difference. And this was our zero term. Okay, so when we did those types of equations, we wrote those equations. Some of those were arithmetic sequences. All right, so what does that mean? Arithmetic sequence, they have a common difference between each term. And yes, my BTW is between, not by the way. So between each term. So 3 to 5, we add 2. 5 to 7, we add 2. 7 to 9. So yes, that's an arithmetic sequence. The next one, 33 to 29, we minus 4. 29 to 25, we minus 4. 25 to 21, we minus 4. All right, so those are examples. So what do? They have a common difference between each successive term. Okay, so going on to the next page. We have determined whether each sequence is an arithmetic sequence. If it is, find the next 3 terms. So basically, does it have a common difference? Negative 4 to negative 2, I add 2. Negative 2 to 0, I add 2. 0 to 2, I add 2. So yes, it is. And the next 3 terms, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. Okay, the next one, 1 to 4, I add 3. 4 to 9, I had 5. That's not a common difference, so no, that is not an arithmetic sequence. Okay, you have you tries, go ahead and pause it and try those, please. Okay, looking at sequences in tables. So sometimes it's easier to look at it if you have the sequence 2, 5, 8, 11. The first term is 2, the second term is 5, third term is 8, fourth term is 11. So we put that into a table. Okay, the term number, and we often call that the nth term, is our x, and then the value is the sequence itself goes into for the y values. So the next 3 terms, well, we add 3 each time, plus 3. So the 5th term is going to be 11 plus 3, which is 14. The 6th term is 14 plus 3, which is 17. The 7th term is 17 plus 3, which is 20. So those are your, not 200, sorry, 20. Those are your next 3 terms. Now the 0 term, if I had to go back 1, what plus 3 would give me 2? Yeah, negative 1. So the 0 term is negative 1. Now the common difference, we add 3 each time. So that's plus 3, 3x, and then plus the 0 term plus negative 1 is minus 1. What does that stand for? The slope times x plus the y-intercept. So the slope, since this is always over 1, okay, for our run, the slope is what our change is, so up 3, okay, and then your y-intercept is what your 0 term is, because we talked about that. When x equals 0, you have a y-intercept, okay, so the x in the equation here represents the n. When we talk about finding, you'll see a lot of these questions say write the equation for the nth term. The x stands for n, so you could write it as y equals 3n minus 1. Okay, so let's do a couple more examples. Here we go, right here. Terms 1, 2, 3, and 4. So 1 to negative 1, we go down 2, down 2, down 2. So that's our common difference. If we find the 0 term, if we go back, what minus 2 gives us 1? That would be 3. So I have y equals negative 2x plus 3, because that's my y-intercept. Okay. For this one, 3, that gives me plus 4, plus 4, plus 4. So that's my common difference, or my slope. So y equals 4x. My y-intercept is when x equals 0. So if I go back, let's see, that would be -1, because -1 plus 4 will be 3, so 4x minus 1. Or you can write that as 4x, or 4x plus -1, or 4x minus 1. Okay, so your turn. Do the you tries, and then pick up the video after that. Okay, so using your knowledge of sequences to write equations. Kristen deposited $200 in a savings account, so she starts with $200. Okay, each week thereafter she deposits her allowance of $15 per week. So the next week she deposited 15, she now has 215. The next week she deposited 15, she now has 230. And then next week she has 245, and so on. So write a function to represent the total amount. Well, what does that change each week? What is that slope going to be? 15. So we have 15x plus the initial value is 200. That's what she started with. So y equals 15x plus 200. Or in function notation, f of x equals 15x plus 200. Okay. How much has Kristen deposited 5 weeks after her initial deposit? 5 goes in for x. So we do 15 times 5 plus 200. Well, 15 times 5 is 75 plus 200 gives us 275. Okay. If Kristen wants to buy a $499 iPad, how many weeks until she has saved enough money? Well, this is how much money she has in her account. So that's where the $499 goes, equals 15x plus 200, and now we solve. We minus the 200, minus 200. You get 299 equals 15x, divide 299 divided by 15 is 19.9. So we're going to call that about 20 weeks. Okay, 20 weeks, and she has enough money for her iPad. All right, so go ahead and do the you try there, and we'll work more in class tomorrow.